let's look at, let me put some numbers here. This is 2 volt, this is 3 volt, this is 1 volt. I am asking what is the voltage here. Now, what is the mark the polarity of the batteries first. First mark the polarity. So this is plus, this is minus, this is minus, this is plus, this is minus, this is plus. Now, you are starting from here and you have to go till here, correct? You have to go from here to here. Let me go from here. If I go from here to here, I am seeing plus to minus. Plus to minus is increment or decrement? It is, yes, it is decrement. Decrement means what? It is like going down. So you are in the ground floor. You went down by 2 floors. So where are you now? You are in basement 2 now, correct? Yes or no? You are in the ground floor. You went down by 2 floors. So you are in the basement 2. Correct? The voltage here will be minus 2 volt. Correct? Now, I am going from here to here now. So this is minus to plus, which is increment. So from similarly, from basement 2, you are going up by 3 floors. I am not going 3 floors up with respect to ground floor. I am going 3 floors up now from basement 2. So where will I go to? Yes, I will go to first floor, correct? So the voltage here at this point will be plus 1 volt. Now, and again I am going now up by 1 volt. I am going again by 1 floor. So I will reach second floor. So the voltage here will be plus 2 volt. So visualize the voltage as floor of the building. Okay, these things are very, very important to understand. Clear? And last thing I want you guys to visualize and understand is this. So this discussion, let us say I have a battery. Okay. So this is the positive and this is the negative terminal of the battery. Okay. Now let us say I am connecting it to a load. Let's say this load is a toy fan. Okay. This is the switch. This is the switch. All of you have seen a switch, right? In your house you would have seen a switch, correct? All of you. Now tell me what happens. When switch is off, or I will say open. Open means what? It is like this. Correct? I will say there is no path for charges to flow. No path for charges to flow means what? No current. No current. So fan is off. Correct? Fan is off. Okay. Now let me look at the same circuit in the other way. This is my battery, positive and the negative terminal of the battery. I have my load, which is the toy fan. And now I have closed the switch. So that means the switch is like this. So switch is closed, on, that is closed. Path, closed path for current. Correct? That's a current. Closed means what it is? Having closed path. Correct? Or rather, if this word closed is confusing, I will remove it. Don't worry about this. I can't remove it. I will say path for current flow. So the current flows like this, correct? Because the current flows, what will happen? Fan rotates. That is, fan is on. So I can say switch is off means fan is off. Switch is on means fan is on. Correct? Switch is off means fan is off. Switch is on means fan is on. I can directly relate to the status of the switch and the status of the fan. Correct? So quickly let us see through what all we discussed and summarize it. Correct? We saw in terms of current and electricity, battery stores the charge and the flowing charge is the current. And one important observation we saw is for the kinetic energy to potential energy conversion to happen in a constructive way. The conversion can happen in a destructive way or a constructive way also. If the potential energy is abruptly or uncontrollably released to change to or to convert it to kinetic energy, the result will be damaging in nature. If we do it in a controlled way, it will be a useful application in nature. Correct? So we need to limit the current. If huge current flows, the battery will get damaged. Correct? So we need to always connect the battery through a load. We should never short the battery like this. Shorting the battery will be damaging. We should never do that. We should always connect the battery to the load. Then we saw the relation between the current, voltage and the load resistance, which is given by Ohm's law, which is V equal to I into R. And based on this relationship, we saw if the current is large, if the resistance is large, current will be small for the same voltage. Or if the resistance is small, current will be large. Correct? We saw that through an example also. And then we saw if multiple batteries are given, how to find the resulting voltage. We assume the voltage of the battery is like a floor of the building. If the battery voltage is increasing, it's like climbing up the building. If the voltage is decreasing, it is like coming down in the building. And based on that, we saw what is the net voltage. And last, we saw the application of a switch. The switch is used to turn on or turn off the load. So these are the things we saw in this lecture. I hope you guys are enjoying. Let's continue to do this. Have more discussion. The next topic we will be discussing will be the fundamentals of logic design. Okay, I hope you guys are enjoying. Stay tuned for the next class. Thank you.